Next, Norton's theorem is so take a look at this example. Find the Norton's equivalent of the circuit given below between the terminals A and B. Now, in this circuit also there are two independent sources. One is voltage source of 12 volts, and another one is current source of 2 amperes. So now our aim is to first Norton's equivalent. And Norton's equivalent is a circuit where you will have one independent source in parallel with resistance, and that resistance, Norton's resistance, is same as the Thevenin's resistance. Now we have to find out that. So how do you find out like here? So to find the Rn, and R, since Rn is equal to RTH, therefore RTH, therefore the circuit is like this. So how do you find RTH? Since this circuit is containing independent sources, so we can apply the method 2 directly. That is series parallel reduction technique. So our series parallel reduction technique prakaram emti independent sources unte వాటిని deactivate చేసి we have to find the equivalent resistance between terminals A and B looking from this end, right? So we have a independent current source here, therefore that you deactivate it, and therefore that you represent as open circuit here. And if you deactivate the 12 volts voltage source, it has to be represented as short circuit. Then after redrawing the circuit by deactivating the independent sources, it looks like this. And this circuit, from this circuit, let us find out Rn. So how do you find out Rn here? See here, if you look at this circuit, when you look at it looking from this end, 8, 4 and 8 are in series, and the combination is in parallel. And the combination is 3 series lo unnai kabatti 3 add chesi 8 plus 4 12, 12 plus 8 20. 20 is in parallel with 5. And then 20 into parallel combination 20 into 5 by 20 plus 5, that is 100 by ohms. Therefore your Norton's equivalent resistance is given by 4 ohms. So now after finding the Norton's equivalent resistance, then you have to find out the Norton's current. So for that one, once again, you what you have to do, the Norton's current can be determined by using the two methods. One is finding the VOC. VOC by RTH will give you IN, or in other words, directly short circuit this terminal and find the current in this terminal like this. See here, we have short circuited this terminal. So that short circuited current ISC we designate it, and that is equal to the Norton's current. So when you short circuit this one, if you look at this circuit, so this appears to be 5 ohms is to be deactivated. Enduku 5 ohms is short circuited. Therefore, current will be confined to this path only, confined to this path, and ఇది deactivate అయిపోతుంది. Now, if you apply mesh analysis, రెండు మెష్లు ఉంటాయి. ఇక్కడ ఒకటి, ఇది ఒక మెష్. ఎందుకు ఈ 5 ohms లేదు కాబట్టి ఈ మెష్ లేదు. So you will have two meshes. One is this one, another one is this. So this mesh we have designated as I1, and this mesh we have designated mesh current we have designated as I2. ఇది మెష్ కరెంట్, ఈ I2. సో అప్లయింగ్ మెష్ అనాలిసిస్, సో కేవీఎల్ అప్లై చేసాం అనుకోండి. దీన్ని చేస్తే ఈ మెష్లో కరెంట్ I1 అని అస్యూమ్ చేస్తున్నాం, కానీ ఈ మెష్లో కరెంట్ సోర్స్ ఉంది కాబట్టి ది కరెంట్ సోర్స్ కరెంట్ అండ్ దిస్ కరెంట్ is same కాబట్టి I1 is equal to 2 amperes. And whereas in this mesh, if you take the mesh analysis, so what you will get is 20 I2 minus 4 I1, right? 4 I1 minus 12, right? So like this, you will get the KVL equation for loop 2. So if you solve, since I1 is equal to 2, you substitute that I1 here, then solve for I2, then you will get I2 is equal to 1 ampere, and I2 is the current in this one. So we want the current in short circuit terminal, and which is same as that. Therefore, I2 is equal to IS is equal to IN is equal to 1 ampere. Therefore, the Norton's equivalent of the circuit is given by a current source of magnitude 1 ampere, that is Norton's current, in parallel with a resistance of Rn, which is same as that of the RTH, which we have found out. Therefore, the equivalent circuit of this one is represented in this way. Now, this is how we find out this. Then the alternative method, the alternative method to find the IN, Norton's current find out cheyadam indaka cheppanu. Inko method emti, VOC katali. We can find the VOC here, and our VOC are VTH, and VTH by RTH will give you IN. So all the ala kartam chudandi. Now we may determine IN from VTH by RTH method, that is. So using the mesh analysis we obtain. So ఇప్పుడు ఇక్కడ ఇలా సర్క్యూట్ లో తీసుకుంటే ఇందులో రెండు మెష్లు ఉన్నాయి, ఇది ఒకటి మెష్. అంటే ఈ మెష్ కరెంట్ I3 అనుకున్నాను, ఈ మెష్ కరెంట్ I4 అనుకున్నాను. సో I3 is equal to 2 amperes, and ఈ మెష్ కి KVL వేస్తే 25 I4, ఎందుకంటే I4 కదా, ఇది మొత్తానికి అయితే 25 I4 minus 4 I3 plus minus 12 is equal to 0. ఇందులో I3 ఆల్రెడీ 2 amperes కాబట్టి సబ్స్టిట్యూట్ చేస్తే I4 you will get as 0.8 amperes. I4 0.8 వచ్చింది కాబట్టి what is the voltage VOC or VTH is same as that of the current in voltage across the 5 ohms. So 5 into I4 will be the VTH or VOC, which is equal to 4 volts. So once you get the VTH, RTH already మనం దగ్గర కట్టును. So your Norton's current will be equal to VTH by RTH, which is equal to 4 by 4 1 ampere. Same answer you got here also. You please look at that 1 ampere. So from that method and from this method also, you will get the same answer in the both the cases. So that is how you will get the Norton's equivalent. Now let us take a look at this quickly. We look at this example to find the Thevenin's and Norton's equivalent of the circuit. So already Thevenin's equivalent dependent sources ఎలా చేయాలని చెప్పుకున్నాను. ఇది ఇప్పుడు మనం Norton's equivalent will find out. So Norton's equivalent find out చేయాలంటే, if you look at this diagram here, you have a dependent current source. So what type of dependent current source we have? We have a current dependent current source we have, right? Therefore, where the current in magnitude of current is depends on the current to the 4 ohms resistor. Therefore, so initially we have to find the RTH, and which is same as Rn. And how do you find out this RTH and Rn? So we can find out this RTH, since this circuit contains a dependent source. Method 1 for finding the RTH we have to adopt. What is method 1 states? Method 1 states that you apply a voltage source across these two terminals where you want to find out the equivalent resistance. So ఎక్కడైతే ఈక్వల్ రెసిస్టెన్స్ కడదాం అనుకుంటున్నారో అక్కడ ఒక known voltage source connect చేయండి with a magnitude of 1 volt. Then find out the current supplied by this voltage source, and the voltage divided by the current will give you RTH. So how do you find out? So when you connect the voltage source here and deactivate the independent sources, ఇక్కడ independent source voltage source ఒకటే ఉంది అంటే దీన్ని deactivate చేయడం, అంటే దీన్ని deactivate చేయడం అంటే అర్థం ఏంటి? It is short circuiting. See here we have short circuited that independent source. So when you short circuit this independent source, what is the current in 4 ohm resistor? Current in 4 ohm resistor Ix is 0. When Ix is 0, what is the current of this independent source? This is also 0. ఎందుకు 0? 0 అయిన తర్వాత అర్థం ఏంటి? This becomes open circuit. Therefore, what is I0 from this? So directly we'll get I0 is equal to 5 ohms series లో కనెక్ట్ చేసినట్టుగా ఉంది. 1 by 5, which is equal to 0.2 amperes. So once you get I0 as 0.2 amperes, then what is RTH or RN? Thevenin's resistance or Norton's resistance are equal to V0 by I0. V0 is 1 volt and I0 we got it as 0.2. 1 by 0.2 will be 5 ohms. This is how you will find out the RTH or RN. Then to find VTH, so we have to find VTH. How do you find VTH? Once again, from the given circuit, in the circuit, in the circuit given, right here, you have to find VOC voltage, open circuit voltage here. So therefore, VTH is the same as VAB here. Then what is VAB here? So if you look at that VAB, it is equal to this voltage 10 plus V5. See here, I have written here. So 10 voltage plus V5 is the VAB, all right? So then how do you find V5? V5 is the voltage, is the 5 into the current to this one. What is the current to this one? See here, it is a dependent current source we have. The current in this one will flow in this direction only, 2Ix. Therefore, your V5 is equal to 2 times Ix into 5. Then what is Ix? If you look at the Ix is the current in 4 ohm resistor. How do you find this 4 ohm current in 4 ohm resistor? This 4 ohm resistor, if you look at that, this is in parallel with independent source of voltage 10 volts. And our current can I able to find the current Ix? Ix we can determine by taking 10 by 4, which is equal to 2.5. Once you get the Ix as 2.5, you substitute that Ix here, then 2 into 2.5 into 5, and that will give you V5 is equal to 25 volts. So when V5 is 25 volts, you substitute that V5 here. So which will be around 25 plus 10. Therefore, you will get VTH as 35 volts. So you will get a VTH. Once you get the VTH, you can find the Norton's current. What is the Norton's current? Norton's current is nothing but VTH by RTH. RTH already is 5, VTH is 35. Therefore, 35 by 5 will be 7. So your Norton's current will be equal to 7 amperes. Like